Good morning and afternoon. It's a pleasure to welcome you to our broadcast titled Real-Time IoT with Utilitywise and Redis Labs. Our presenters today are Jonathan Wilkinson, Innovations Director at Utilitywise, and Roshan Kumar, Senior Product Marketing Manager at Redis Labs. Over the next 50 minutes, you will learn about Utilitywise's real-time IoT architecture and the best practices implemented with Redis. You will also gain insight into how Redis Pack helped Utilitywise reduce application downtime by 50 to 70% with 300% higher performance for their IoT application. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. Jonathan and Roshan will be taking questions throughout the broadcast. There is a question and answer feature in the control panel that you can use to post questions. Those questions will be answered in the order that they were received. We want to thank you again for joining us today, and at this time, I'll turn the broadcast over to Roshan. Roshan, take it away.
Thanks, Sharon, and thanks everybody for joining the webinar. IoT is a hot topic in today's market, and the kind of innovations happening in this field is just so amazing. Now today, we'll talk about Utilitywise. Now Utilitywise is a UK-based IoT company, and they're doing some great stuff. And Jonathan is going to present what Utilitywise is doing, and also he will give a demo of one of their products. And also he'll talk about the key role Redis plays in their software architecture. In the interest of those who are new to Redis and Redis Enterprise, I'll give a very quick introduction to Redis Database and what Redis Enterprise is about. Now before we start, there is a raffle today. We're going to ask some questions. There are some polls, and those who participate in the polls will be eligible for the raffle. As many of you know, Redis is an in-memory database platform, and it is particularly known for high performance. And Redis Labs is the home of Redis, and it sponsors the open source project of Redis. And also it offers the commercial Redis Enterprise product for enterprise customers. Now talking about Redis, as I said earlier, Redis is known for performance. And we have many benchmarks on our website, and you can go to our website and look at those benchmarks. And in a nutshell, we have the highest throughput among all databases, and also we do that with the least latency and with the least amount of resources. And about data structures, Redis provides some native data structures such as lists, sets, hashes, and so on. And these are like Lego blocks for the programmers. And this brings in many advantages. Now, if you're programming to a list, you program to the list directly in the database itself. And the programmers or architects, they don't need to manage translating the data structure information to the native database form, because the native form itself is the data structure. Now, Redis is highly extensible. I'll give an example here. Suppose you want a search engine. All you do with Redis is you just import the Redis search module. So when you import Redis search module, you have the search engine ready for you. And similarly, you can just import a time series database, a time series module, and you have the time series database. And there is a graph module, and you have graph database. So Redis database is so powerful. By just importing these modules, you can custom use the database for your needs. Now with this, Redis powers many use cases, right? From high-speed transactions to caching to time series, job and queue management, and so on. And it also powers many solutions. And wherever there is real-time, Redis is there. And it powers many solutions ranging from IoT to e-commerce to fraud detection and so on. Okay, now we are at our first poll. I'll ask a question, and the question is, where are you in your NoSQL journey? And the poll will come on your screen right now. Okay, we will move on. Okay, I will share my screen. Just give me a second here. So can you share my screen? Can you make me the presenter, please? Okay. Now I'll give a quick introduction to Redis, what Redis Labs is, and the Redis Enterprise technology. Now, assume you have a few Redis database instances, or you could just have one Redis database instances. And what Redis Enterprise does is it gives a layer, it adds a layer on top of Redis, open source Redis databases. And on this enterprise layer, you get a cluster manager, a zero proxy, a zero latency proxy, and REST APIs, and many more things. Now, with cluster manager, there are many features you get. For example, you can add more instances without any pain. You can scale linearly, and also cluster manager, it manages all the sharding and resharding, and also balancing of data. If the data is concentrated on one of the instances, it moves around, and also you don't have to bring down the database if you want to add more instances. It just manages all the new instances without having any downtime. With the enterprise layer, we also have something called Redis node, and this gives a Docker-like container architecture. Now with this, you can take the container, the Redis node container, and you can deploy them as a cluster. And you can enable replication for high availability, and also there are many cool things such as it maximizes the CPU utilization, and also with the cluster Redis cluster, you get ACID support for your transaction in a cluster and not just in a single instance. So this is Redis technology in a nutshell. And how can you get this Redis technology? There are two ways. One is you can go to Redis Cloud, and you can get Redis Cloud. Redis Cloud is a fully managed Redis service, and it's available on all popular cloud platforms such as Amazon Web Services, Azure, Google Cloud Platform, and so on. It's also available on the popular platform as a service providers like Heroku, Cloud Foundry, and so on. And it makes sense for you to go for Redis Cloud if your applications are already on the cloud, because staying the database, putting the database close to the application helps you with performance. Now, Redis Cloud Private allows you to use Redis within your VPC. And once again, Redis Cloud Private is available for AWS, Microsoft Azure, and all popular cloud platforms. Now, suppose you have your own data center and you don't want to go to cloud. Redis Enterprise is available as Redis Pack, and it's a downloadable software. You can download Redis Pack, and you can manage Redis Pack within your own environment and manage all your Redis instances. Right. Now we are going to poll number 2. I'll hand over to the organizer for running the poll. Yeah, please select the appropriate answer. You can select all the answers, or all of them, if everything applies to you. All right, we'll move ahead. Okay, I will hand over the presentation to Jonathan. And Jonathan, I will hand over, I'll make you the presenter, and we look forward to hearing what Utilitywise does.
Okay, thanks, Roshan. Okay, okay, let me just start this. Okay, well, thank you everyone for joining us. I'll quickly introduce myself. I'm Jonathan Wilkinson. I'm Innovations Director at Utilitywise PLC. I work in a R&D division at Utilitywise, and I work with about 20 web developers and data scientists, and we're making innovative cloud-based solutions. So we're working in the energy sector, so we've got customer portals where people can view their energy consumption, and we've got our IoT energy management system as well, which is a device that you can install in buildings and control devices in there. And I've been working in the energy management industry for over 14 years. Utilitywise is a UK PLC. In essence, we're an energy broker, so we help our customers get a better deal on their energy procurement. So that's anywhere from your gas, electricity, and water. We can get a better price than going directly to the utility suppliers. We also have energy services division, which helps our customers with all sorts of energy needs, so we can actually help people reduce their consumption as well. We've got about 30,000 customers, and they range from really small buildings, so think of a small cafe or sandwich shop, up to much larger businesses such as manufacturing plants. We manage over 20 terawatt hours of power, and by managing that means we're purchasing power on behalf of our customers. We're a one-stop solution because we can handle all your utilities, and we can also help with legislation as well. And we save our customers millions of pounds a year by reducing their CO2. So what is WiseLife IoT? So WiseLife is the name we've given for our IoT platform. It's a building management, or very similar to a smart home device. So there's a gateway goes in a building, and then you can attach sensors, either wired or wirelessly, to monitor aspects of your building, of your commercial building. So we look at things like gas and electricity meters. By monitoring your energy consumption, you can help identify where to make savings. And then we control things, sort of energy, and we control things that consume energy. So your boiler to control your heating, thermostatic radiator valves. On the radiators, we control air conditioning and ventilation systems. We can control your indoor and outdoor lighting. And again, we can attach other types of sensors as well. So we can have a door and window sensor, much like a security system. So we know if people have left the windows open, so we can turn off the AC or turn off the heating. And we can monitor temperature and light, and also presence. And we have a smart plug as well. So this is a small device that you can plug into anything that's got a socket on there. So think of, I don't know, a TV or a Xerox machine, or a coffee maker or something like that, and we can control that through our iPhone app or Android app. So this is what our app looks like. So it's been designed to work on smartphones and tablets, and we'll give you a quick demonstration of this later on. But if I just go through what each of the screens are showing. So on the first screen we have tiles which the users can customize, so they can easily turn things on and off if they want to. They can see the status of their building and look at the temperatures and energy consumption. On the next slide is a list of all the devices or sensors that they've attached to the WiseLife gateway. So we've got plugs, thermostats, electricity meters, windows. The next page is what we call our live page, and this is the bit where we're really utilizing Redis. So when a customer clicks on a particular device, they get a live feed or a live stream directly from the device on in the building to their phone over the cloud. And this page here is just showing how you can set up schedules for a particular device. So you can say, for example, if you want to control your lighting, you can turn your lighting on between say 8 AM in the morning until 5 PM at night. So we were asked, why did Utilitywise choose Redis Pack? Well, we needed an in-memory cache for our web applications. So we've got a web farm, and we needed each of these web servers to be able to have access to a distributed cache, mainly to improve performance. Before that, we were using Microsoft SQL Server, and the load was just increasing on the SQL servers. So we were looking to reduce the load as well. I mentioned we needed it to be shared across the web farm, so we couldn't just have cache on each web server, because obviously the data could be served from a multiple of different devices or different servers. We're a Microsoft house, so all our developers are using Microsoft.NET, so we needed a database that we could support that. And uptime was really important. Because we're controlling people's buildings, people can use their building any time of the day. They may need access to their data. So we wanted pretty much almost 100% uptime. And we found Redis was very popular in the marketplace. Our developers look at Stack Exchange, and Stack Exchange explain how they do their architecture for their websites, and we could see that they were using Redis in there. And more than that, they were actually promoting their own .NET client, which we actually use. Other reasons we chose it was it's easily scalable, so we can easily add more nodes and shards to the cluster, and add more memory as well if we need to. And it was really easy to install. I'm the guy that's sort of installing and maintaining the cluster, and installation, once you've got your operating system on, installation for a node is probably less than 5 minutes. You download it, run a script, and it even does a sort of best practice configuration for you. So you just like configure your firewall, configure the swap, and all those sort of things, and just press yes to those, and it's pretty much configured straight away. So it's relatively easy to install, and even upgrades as well. So obviously you need to use the latest version for security, etc. Upgrading nodes, you just upgrade one node at a time, and then your cluster is upgraded without any downtime or loss of data. So what are we using Redis Pack for? Use cases. Some are a little bit easier to explain. So the reason we wanted to use Redis was because we were streaming data. So the device on the site streams data up to the cloud to the user's phone, and we needed that to be quick, so it was responsive. So if someone made a change on site, they could see the change was instant through the app, and we wanted it to be less than 1 second. So we use it mainly for streaming data, but also we've put it for use for other applications as well in our architecture. So we've got a lot of data in SQL, and some of the queries were quite slow, or they're heavy queries because they were doing a lot of processing. So what we did is we will cache the results from these SQL queries and store them in Redis. So when the user or the device connects to our application, the results pretty much instant there, rather than going to SQL and waiting for that. Again, that reduces the load on the SQL. Another application is we store windowed data, so for function processing. So a really simple function might be just adding 2 values together, so values 1 and 2 together. But what we're doing is the data from, say, value 1 and 2 may come in at different times of the day. Not all the data is live. So we may get data for, I don't know, at midday for one site and at 5 o'clock for another site, but we need to add those 2 values together. So rather than going back to the database, we store these values in memory in Redis, so then it can go back into our database for processing analytics. And another application for our IoT software is we're using Azure IoT event hubs. So as part of that, we need to deduplicate messages from there before we put them onto our Rabbit message queue. Okay, how did we configure Redis Pack? So we're configured in on our own servers. We co-locate our servers in a data center in Derby. We're running the nodes as virtual machines, and we're using Microsoft Hyper-V as the hypervisor on there. We're using CentOS 7, and each node's running, it's got 10 gig of RAM and a 200 gig hard drive. We're using the replication, so that's enabled, and we're also using persistence, and we're using the AOF fsync every 1 second. We're sort of, our developers were debating whether we needed persistence or not. It's a feature that Redis offers, so we've got it enabled, and it doesn't seem to affect any of the performance for us, so we've got it enabled, but we don't exactly need it because it is just a cache, so it would get rebuilt if we lose it. And the type of data we store is mainly JSON data, and we'll have a quick look at some of that data in a second. So I've put a slide together to sort of explain our architecture. We've got a number of different technologies. So we've got, we're using Cassandra and Spark from DataStax. We've got our Redis cluster here, and we're using Microsoft SQL Server as well. So if we just look in this bottom left-hand corner, so in each of the building there's a field gateway, and that field gateway is then connected to our sensors or actuators in the building, either wired or wirelessly. And we've got two sort of ways that it sends data. So we've got the streaming data, which will come through our Microsoft Azure IoT hub, and we will then consume that data. So it'll comes into Azure, and then we get it into a routing module. It goes onto a Rabbit message queue, and then into Redis, and then that streaming data can come all the way back out through to the web server onto the mobile app. And I'll give you a demonstration of how that works. We then split off streaming data and periodic data. So periodic data is sort of histories or sort of the time series data. So we don't send that through Azure. So historic data or periodic data gets sent just to a web endpoint there, added to our message queue, and then that goes into our Cassandra and Spark cluster. So the time series data is stored in there and also aggregated as well, so so people can look at that later. I mentioned we cache our heavy SQL queries as well. So we have something called a cache builder module here. So what that will do is it will take the data out of SQL and store it in Redis, ready for use. And the final thing is what we call commands. So a command might be, a user might be wanting to switch a device on and off. So switching the lights on and off on the mobile app, so that's called a command. That comes into Redis and then back out into our command queue and back out over Azure to the field gateway. So what I'll do now is I'll show you how, if I just leave this section up, so I'll show you how this live streaming part works. So what we've done is we've created just a little application that mimics the gateway. So what it does is it's sending values every 5 seconds, just a random value between 0 and 30, as if it was the gateway. And if we just look, this is just a free Redis GUI that we're using. So we connected to our live Redis database. We've got a hash or key called latest data. So if we just run a hash get, so latest data, that's our hash number, and this is just the ID of this client. We can see this is we're storing JSON in there, so you can see the value, the date and time is updated. So obviously the 16 was in there, so we run it again, we get the 13, and then run it again, we get the 16. So you can see the values have been updated into our Redis database. Now, if we look at our app, so I've just opened up the app in a browser, just with it set to the size of a normal phone. We can see here this value that we're streaming in, it gets streamed straight up to there, so it's gone to 18, 15. So you can see the latency's less than 1 second, which is what we were looking for. So pretty much it's instant. You can't really tell that there's any delay on there. And that was one of the main reasons we wanted to use Redis. People wanted to see things happening instantly, and it doesn't cause any performance issues on our SQL database. So that's a very quick overview of how we're using Redis, and I welcome any questions that you have. I'll pass you over to Roshan.
thanks, Jonathan. That was an impressive presentation and a great demo. It was really nice to see how Redis fits in to the architecture and how your customers can control things in real time. So that was really great. And thanks a lot for showing your stuff. That was wonderful. Now I'll give a quick overview of how Redis fits into the IoT architecture. If you look at a general problem that everybody tries to solve in IoT, it's about getting all the data, the streaming. You need a streaming API, and you stream all the data from all the sensors, from different sensors, and you collect all information. And you need a solution to buffer all the data that comes in at different speeds and so on. And then you need a time series database to store all that information. So this is a typical use case. You see this in almost all IoT architecture. And the great thing is Redis fits in very well for all the stuff you do, whether it is streaming or whether it is managing the data in a job or in a queue manager, or whether to have a database that stores data in the time series fashion. So Redis is perfectly suitable for all these use cases. And also, another thing that we saw in Utilitywise example 2 is the presentation layer, where you need to present data in real time and manage stuff in real time. Typically, you have an analytics engine or an AI solution such as Spark, and Redis has a Spark connector. And it got a lot of interest, in fact, at the Spark Summit 2 weeks ago. So you can deploy Spark with Redis Spark connector, and you can directly access data from Redis. And that's another powerful way of using Redis. Now, in IoT world, there are many solutions. When we talk about IoT, we talk about smart homes or smart cities, or it could be inventory management, or energy management. We just saw an example of energy management. Now, to power all these solutions, you need application, you need solutions, or you need use cases such as a time series database or job queue manager and so on. And all these are readily available with Redis and Redis Enterprise. So Redis Enterprise makes your architecture really powerful, and you will be able to achieve all the stuff you're doing in real time. Now, another thing that comes to mind is the cost. Now, Redis, by default, it runs on, it's an in-memory database, it runs on RAM, and you may question, hey, deploying Redis on RAM is going to be very expensive. And for that reason, Redis Enterprise has a solution, and Redis Enterprise can be deployed on RAM and Flash as a RAM extender. What happens here is Flash acts as a RAM extender, and Redis Enterprise stores data in a tiered model where all the hot values are stored in RAM and all the warm values are stored in Flash. The values that are not accessed frequently are stored in Flash. And this saves data, this saves cost significantly. And just to give you an example, here is a 30 terabyte installation with Redis on RAM, and on an yearly basis it costs about $2 million. And if you deploy Redis on Flash, even if you increase the size to 60 terabytes or 60 plus terabytes, with Redis on Flash, you can bring down the cost to a few $100,000. So you have about 80+% savings with Redis on Flash. And keep in mind, Redis on Flash is available on Redis Pack, and it's also available on Redis Cloud Private. Okay. So that is about Redis for IoT. And to conclude, Redis Enterprise is extremely powerful. It helps you to scale effortlessly. If you are planning to deploy a Redis database, then Redis Enterprise is the way to go. You can scale linearly, and the cluster manager that's available in Redis Enterprise, it manages all the scaling and adding new instances. or rebalancing, resharding. Cluster manager takes care of all those things. And also in the cluster architecture, if you're looking for an ACID compliant database, Redis database, you get that in Redis Enterprise. And also talking about always-on availability, it's a highly available solution. Just to give you the scope of it, we manage about 250,000 databases, Redis database instances, and we have had more than 1,000 node failures on the cloud, and we have not lost data even once. So that is the track record of our high availability. So even with 1,000 plus node instance failures, we have not lost data even in a single instance. So it's a highly available solution. You can enable replication, and also it supports disaster recovery and so on. Now about costs, if you want to save money with Redis, Redis Enterprise is available on Flash. Flash has a RAM extender, and I just showed you how much you can save with going with Flash extension. So that is about Redis. So this is a wonderful product, and you can sign up. You can go to our website and sign up for Redis Cloud for free. And you get there is a freemium model, so you can sign up for free, and you can use it, and you can upgrade as you want more to do with it. Okay. Now I will go to poll number 3 before we take questions. So I will change the presenter. We'll quickly go to poll number 3 and take all your questions. Choose the Redis product used by Utilitywise. Okay, I will get back to presentation. Okay, it's time for some questions. We have some questions here. I'll take the first question here. This question is for Jonathan, and the question says, that's fantastic, Jonathan. What other vendors did you look at, and why did you choose Redis? And Jonathan, could you take the question, please?
Sorry, I was on mute then. Yeah, so we mainly, because we talked before we were a Microsoft house, we initially started looking at Microsoft in-memory tables, but it made it expensive because we would have needed another Microsoft SQL Enterprise license to separate it, because we were trying to reduce our server load. So it was very expensive, but Redis and Microsoft were the only ones we really looked at in earnest, really. But like we said, a lot of our developers had heard of Redis before, and we've used the open source Redis before, so it was kind of a natural fit, and it was reasonably priced as well, so it didn't put us off.
Great, thanks. There is another question. Again, this is for Jonathan. Jonathan, you said you use Redis for deduplication. Could you explain how you use Redis for deduplication?
Yeah, so we're using Azure IoT event hubs. So every time we get an incoming message, we will store the message GUID in Redis. So then when we start to consume messages from the hub, what we'll do is we'll look to see whether we received that message before. So we'll check in Redis to see if that GUID already exists, and if it has, we won't process it. If it doesn't exist, then obviously we'll add it into Redis. And then process that. But what we'll also do is, say, like every sort of 5 minutes, we'll create a snapshot in time from the Azure IoT. So then, if we ever needed to, if there was a failover, for example, or crash, or server crash, or something, or service, then we could go back to that snapshot in time and again look at which messages we'd already processed.
Okay. And Jonathan, I'm just curious, do you use set data structure when you use Redis?
Yeah, for the deduplication, yeah, that's exactly what we use. We use a set.
Oh, great, wonderful.
Yeah.
Okay, I have another question from the audience. It's about failure. With your Redis pack, have you encountered any failures, and how resilient is the solution?
So touch wood, we've not had any failures yet. So we've had 100% uptime, and even that's included taking down, like we mentioned, we're running them on Microsoft Hyper-V servers. We've rebooted those and we've upgraded Redis in the meantime, and we've still had 100% uptime and no data loss.
Great, wonderful, wonderful. And then there's another last question. It's about the software stack. What's your software stack, and what client do you use to connect to Redis?
Okay, well, we basically, most of our software is .NET software, but we're using the Stack Overflow. So if you go on GitHub, Stack Overflow have put their own .NET connector on there, and we've been using that one, which seems to be really good. But yeah, we're mainly .NET. There's some Java and Scala in there for the Cassandra and Spark part of the architecture as well.
All right. So those were the questions. Thanks for asking those wonderful questions. And Jonathan, thanks for answering them. It's really nice to know how Redis plays a very important role in your architecture. Okay. And if you want to contact us, everybody, please contact us. You can go to redislabs.com and sign up for the free service, as I said earlier. Or you can send us an email. And if you have any questions for Jonathan, you can send him an email, or you can get more information about Utilitywise on utilitywise.com. All right, thanks everybody, and I'll hand over the presentation to Sharon.
Wow, what a great use case from Utilitywise. Hey, thank you, Roshan and Jonathan. And thank all of you for joining us today. An email will be sent with a link to the recording of today's broadcast. For an overview of upcoming webinars, please visit redislabs.com and register. Go out and make it a great day, and goodbye for now.